Welcome to Virtual Conservation Live. If this is your first time joining us, welcome to the party. If you're a longtime viewer, welcome back. We have an interesting presentation today about science we can all do anywhere. But before we get to that, we're going to go over some ground rules. The Q&A box, if you're on Zoom, the Q&A box is for asking questions of the presenters or answering questions that the presenters might have asked for you. It's not for chatting with friends. It's not for making jokes and doing things like that. So let's keep the Q&A box clean. If you're joining us on Facebook Live, we are going to try our best to monitor the questions on there and try to get them answered live. If we don't get to them live, we will respond to your comments and your questions from our presenters. So without further ado, my name is Wag Lightner. I work for the Tippecanoe County Partnership for Water Quality, and all of the fourth graders on Zoom, I think, know Miss Christopher.
Hello, everybody.
This event is intended to take place of the Conservation Field Day, which is normally a live, hands-on, place-based learning opportunity for fourth graders in Tippecanoe County. Because of the virus, we're unable to do that. So we're happy to come to you virtually for conservation work. Without any further ado,
Facebook Live.
Already did it.
Oh, okay, sorry.
Steve and Sarah, take it away.
Yeah.
All right. Well, thank you for having us on here. We regret we didn't get to see everybody live and in person, but this is the world these days. Sarah and I put together for the live one doing hydrology stuff. And hydrology things are about water. But since it was going to be a little harder to do that, especially with me being accident prone and right in front of my computer, we decided we would talk about atmosphere. And so the air all around us. And so Sarah and I are part of a program called GLOBE, Global Learning Observations to Fit the Environment. It's a NASA-sponsored program that is throughout the entire world. Over 120 countries are in it. And the really cool thing about GLOBE is it is literally for all of us. It's for us to collect data, and we share with NASA scientists, and they do really cool stuff with that data to help figure out things about the world around us. And so we want to share some things about that with you today, and then show you how you can actually do this anywhere you are. I was talking before, well, a week ago, we were chatting about what we were going to do, and I was telling people that my daughter, who was in middle school, she would, every day after the bus, she would go do cloud observations for the GLOBE program right at school. And I thought, well, that's pretty cool. And so this is something anyone can do. Now, Sarah, you want to jump in and start explaining the first activity there?
Absolutely. So the first activity that we have, a lot of you could probably do this right in your own homes, and it's going to require two different colored pieces of paper, about a printer sheet, regular size sheet of paper. So Stephen's showing a blue sheet of paper and a white sheet of paper. But if you don't have blue and white, you can use any other two. It's better if you have two contrasting colors. You could really even use if you just have magazines, or depending on what you have, you could just use anything that you're going to notice a difference. And one thing we want to do, we're going to talk about clouds. And so we can all observe the clouds in the sky. And NASA scientists actually need our cloud observations to help them understand the satellites that they're using and the satellites that are orbiting the Earth. And so what you can do before, we're going to show you how to go online and help NASA take cloud observations of your sky. But before we do that, we have to adjust our eyes so that we can make good estimations of how many clouds are actually up in the sky. So one way you can do that is you can practice with different percentages. So thinking of a percentage and then making that percentage of cloud cover on your sky. So using the white paper for the clouds, for example, and then using the blue paper, that's what you would glue them to. And I'll show you some examples of that here in a minute. And then just having somebody else kind of guess what your percentage is, and then reversing that. So then having someone else make a sky, and then you guessing that. And once you feel pretty good about those estimations, that sets you up to be successful then to go outside and use the Globe Observer app to estimate the clouds that are in the actual sky. So do you want me to go ahead and show a couple of those examples? Okay, so what I've done is I've prepared a sample sky here, And so you can think about what percentage of cloud cover do you think I'm showing on this blue sheet of paper? So you can think about it for a minute.
Does
You
anyone
can just
have a guess? They can put it in the chat box. We got 80%, 86%.
Ooh, that is really close. This is actually an 85%.
Wow.
So that's an excellent. So we'll say we're 1 for 1. So let's look at a second one. Oh, and so yes, so then to prove it, what I did on the back, I put the remainder of the white paper that I have showing here. So I had separated my white sheet of paper into 10 squares. I had to do a little bit of measurement to get that. And so what I have is I have remaining one of those 10 squares and then a half of the 10 squares. So 15% remaining and then 85% then of the blue. Okay, so now Stephen's showing one. So what are some good guesses? How much cloud cover?
Stephen,
Cloud cover.
What?
Make some noise so you show up.
Oh, make some noise. I'm sorry. I'm usually rambling. People ask me to stop making noise. This is different. What do we have here? What kind of guesses do we have?
We have a 15%,
The 15?
16, 28,
You guys must think I can do better math than you.
maybe 20,
Easy number.
78, 15.
25%.
Yeah, 25% is what I picked. I did 25%. And whenever we do these, and you can test this, you can test each other and quiz each other. You're calibrating your own eye and your mind to see what percent of the sky is covered. And we always prove it. See, I tore my piece of paper into fourths, and there's the part I took out. And so now we can always, we just put these up usually around, and then we can look at those and calibrate our own eyes to see how well we can guess. And it really gets you estimating a lot better. And so it helps us with our estimation skills.
Do one more?
Sure.
All right, do one more.
Okay. What percent cloud cover do we see on the blue paper?
99%.
75. 75. 35.
99, 75.
50, 66, 70.
Well,
Right.
the 66 was pretty close. This is a 60%.
Wow, good.
Mm-hmm.
Someone's got good eyes.
Yeah. So again, like Stephen said, it takes just a little bit of practice to start calibrating our eyes to think about what percent of the sky is covered by the clouds. And once we feel good about that, we're able to get onto some sort of device and bring up the Globe Observer app. And I believe Stephen's gonna help walk us through where we can find that.
Yes, if we get, and what's really nice is it doesn't matter if you have, I use my iPad right now, but I usually have it right here on my phone. It's just a little Android phone, so it's cross-platform. We can use it for either one. Oh, and I'm getting an email. I hope it's not one of you guys. But I went ahead and I've downloaded it to both of them, and I made an account on the app itself. And so what I did was, we're starting to see my reflection of my, you can see my, you can see my, my Star Wars clone trooper. Anyway, all right. So what I did is I opened it up, and as we can see, we can do clouds, we can do mosquitoes, and talk about mapping where mosquitoes are. And this is a great year to start. This is a great time to start thinking about where could mosquitoes be. And it helps you map out where mosquitoes can be. And so land cover, so what's covering the ground? These are really good things that any of us can do. This is a citizen science program, so anyone in the world can do it. And then trees. I'm going to tell you, just a small secret. The trees is my favorite because we get to figure out how tall they are. And that's like really, really neat, being able to figure out how tall is that tree when we're looking at it. We can use that app to figure out how tall that is. And so that's so much fun. All right, but we're talking about clouds, right? And so I'm going to click on clouds if I can do this backwards. Oh, I did. All right.
Remind us what the app is or what the web address that students could go to.
I'll pull that up in 1 minute.
Okay.
1 second. This is Globe Observer is the name of it, Globe Observer. And I have and if you search in the Play Store, Globe Observer, Now there's a globe data entry. We don't want that one. That one's for like teachers and stuff to do the schools things. And so we want the globe observer one. That's one we can do anywhere. And so it's on my phone, my iPad. My daughter has it on her phone. It's like, well, pretty much if you know me, I've made you put it on your phone usually. So we're going to do a new cloud observation real fast. And here's the really cool part. It asked me where if I'm doing it. And so Sarah, what's that code? Capital I, capital N,
lowercase science.
So if you sign up for it, it'll ask you if you want to join a school, put capital I, capital N, lowercase science. So Indiana Science, right? IN. And that will join our big team. So we can see how many people is actually putting data up. And I'm hoping to see a lot of people do that this week. And so when you download it and you make an account, it'll ask you for that. So it's not a real big deal. It's not a requirement, but it's really kind of neat. That way we can see each other's data. And anyone in the world can be able to see our data, which is really cool. And so now it's just going to say where I am in life. I'll skip through that. Then it'll say, are there clouds? And so here's the really cool part. They have a new thing. Oh, we just talked about percentage of sky cover, didn't we? Well, that's the first question. That's why we talked about it. All right. And so what's happening is say, are there a few clouds? Is it isolated, scattered, broken, or overcast? Now, my sheet was 25%, right? And so that would be scattered clouds. When we see the weather report coming up and it says, oh, it expects scattered clouds. Well, that means between 25 and 50% of the sky will be covered with clouds. So now NASA, they'll look at with the satellites down at the Earth and they can see how many clouds are there, but they need us to look up at the sky to tell them how many we see. And that helps calibrate those satellites. So we're actually helping scientists make better weather reports by putting our stuff up there. And here's the really cool part. I'll delete this one since I'm not outside and I don't actually know what it is. So next, it's going to ask you things like how dark is the darkest part of your sky? And so you'll look at the darkest part with the sun behind your back, look at the darkest part, and I'm like, oh yeah, it's blue, I see that. You know, say, is it hazy outside? You know how some days it's just like not foggy, but really hazy. You look on the horizon and it's not foggy, but it's just not that clear. That's because it's hazier. All right, we'll discuss what that means some other day. But now, here's something really cool they have. Let's say you've not studied clouds and you don't know clouds for sure. They have two ways. You can say, oh, you can put the manual one and click and did compared pictures, or they now have a cloud wizard on there. And so it'll ask you different questions and go through with pictures and help you figure out what type it is. You might not know what a cumulus cloud is. Well, it actually will guide you and teach you about what types of clouds are. So when we go back to school in August, you can tell your teacher, hey, I already know all about clouds because I did the globe thing all summer and I checked it out. You know, so you could teach your teacher about these things. Now, I told you all right, so so if you have your own phone, ask your parents permission, have them install it. Or what we did before my daughter had her own phone, she used one of our phones. So we put it on ours and made it like a family account that we shared. And so then she would just borrow either my wife's phone or my phone. Then she would always be borrowing it and doing cloud reports, which is really cool. That's a fun way of using it, isn't it? Now, if someone, and you can do all of the registration right there in the app. You don't have to go online, but obviously if you're watching this, you can go online. And so what I can do really fast is share the Globe Observer page. And so this is just, as you can see at the top, it's observer.globe.gov. And so here's the actual Globe Observer page. And so we can go on here and of course you could hit get the app where you lead you to the app to download, or you can just like search the store, you know, and this will tell you all kinds of really cool things about the Globe program. The trees thing I mentioned, they have a thing to show you how exactly to do the tree height. There's all this information and they'll tell you, you know, what's the most recent data that's going up in the last 7 days? Where are they all? You could click and say, where's the cloud cover? Look at all that cloud cover. People all over the world are reporting what the clouds look like, which is really, really cool. And so they talk about the cloud wizard, what's new, what's going on. And on the sign up, click that sign in that we talked about. And Here, join globe right there. We could even join it right from the computer. And so you wouldn't have to do it on the phone itself if you don't want to. You just have to make sure you ask your parents, have an email account, and join globe. And we talked about an organization right here. That would be Join a Globe School. And that's where we're going to type in capital I, capital N, lowercase science, SCIENCE. And so that's where we would type that code in. Oh, look, and it popped up, Purdue University Virtual School, Globe School. So now you'd be with all the people all over that's part of that. But that's really easy. I'm not sure where I am on time. I got a feeling we're about out with that. Sarah, do you have something else to add real fast?
Just that every measurement that you make is also, it's going to help with those satellite measurements of the clouds. And you can make cloud observations anywhere. I know that sometimes, well, Stephen talked about doing cloud observations with his daughter, but I've also done cloud observations with my children as well. Sometimes if you find out you're outside, maybe you're waiting in line this summer to go do something. While you're waiting in line, if you're outdoors, you can take a cloud observation there. Anywhere that you have an internet connection, and even if you don't have an internet connection, you can, if you can pull up the app, you can still wait until you connect later to it, to either a Wi-Fi or internet service, and you can wait to upload the data there. But I know that every cloud observation that you take is helping NASA scientists.
Cool. That's awesome.
My iPad does not have a cell phone stuff. It's Wi-Fi only. And when I do mine outside, then when I go in back home, then I can just upload them then.
We got a science question for you guys. How do clouds stay up in the air? I know we're talking about clouds right now, so give me some basic science here.
Sarah, you want to take it or you want me to hit that?
You go ahead.
Okay.
You go ahead.
Well, when it comes down to it, they're less dense than the air around us. And so for their size, they're lighter for their size. Density is about size, right? Than the particles around us. Just like when you have a helium balloon, it rises up, right? And so it's less dense than the air around us. Now, clouds form through, it has to have a piece of what we call cloud nuclei, or could be anything in the air, dust even, and stuff like that. Then water, really fine water vapor, starts off vapor, then it condensates on cloud nuclei to form a liquid water, condensates in liquid. Then when that's heavy enough, it drops out. That's where we get rain, like the rest of this week.
All right, one more question on clouds and then we'll move on. Are clouds actually white or are they clear?
That's an awesome question. And so with the white color that you're seeing is from the sun scattering. So every little water droplet that Stephen talked about that condensates on a cloud nuclei acts like tiny little prisms. And so those tiny little prisms scatter the sunlight. And so it appears white because it's scattering, and we're seeing all of those wavelengths of color, the red, orange, yellow, green, blue, indigo, violet, all together. And the presence of all of those wavelengths is giving us that white color.
Awesome. All right, continue on. No more clouds.
I don't know where we are on time, how much time we have. You guys, you gotta be careful with me.
Okay. You got about 10, 12 minutes until we finish up on questions. So.
Okay, if there's more, just stop us. Now, with the Observer app, we talk about the Observer app. Of course, we talked about clouds because we're really excited about all the clouds that you can do. And I mentioned on the habitats with the mosquitoes, how we can actually look for different habitats for mosquitoes. And that's something that's very important that's coming up with the spring is looking at habitats. So mosquitoes, they lay their larvae in water. And so we're looking for where is somewhere that might have water setting there. And for me, heck, I found some spots in my backyard. Yesterday when I was out, I was mowing and I glanced over and some of our old flower pots were sitting over there. I'm like, oh no. And I got looking and some of the buckets that was beside them, they're full of water. I'm like, well, that's mosquito homes. And so I poured those out right away because I don't want mosquitoes that are living around my home. And so I poured those out right away so I could stop and kind of have less mosquitoes hopefully this summer. And so it walks us through looking for things where mosquitoes might breed. And there's even, you'd have to order, they're like, I don't know how much they are online. I think they're $5 or $10, little bitty microscopes that you can clip on your phone. And then you use those to take pictures of mosquito larvae. So you can collect the mosquito larvae, and you can take pictures of those with your phone, and you can send that in, and you can help identify what species of mosquitoes are around. They actually used this to track like the Zika virus as it was traveling through North America. That's what they used this app for. They could tell because only certain species are responsible for that virus. And so there's is virus the right word? Yeah. Okay.
Yep.
I'm all of a sudden, wait. And so that's one of the reasons the mosquito habitat mapper is really important and a really good thing for science to do. There are some countries, like I believe Taiwan, if I remember right, when we were talking to someone from Taiwan last year, that most of the schools in Taiwan do this. And so they actually have all the kids doing GLOBE as a part of their education, and they go out, and I saw a bunch of presentation from Taiwanese students where they were mapping their areas looking for these types of things.
And the really nice thing about the Globe Observer app is even if you've never used it before, it's going to walk you through step by step and say, now this is what you do. Now use your phone, point your phone this way to take the best picture. It's going to tell you step by step exactly what to do.
Mm-hmm. And it really makes it super easy for us to use. We don't have to be like a scientist, know everything about a particular topic, because they walk us through, because it's designed for us. It's designed for people that doesn't necessarily know everything about a topic. I mean, when it comes to mosquitoes, I definitely don't know. I've always said if it's living, it's not my problem. And so mosquitoes aren't my thing. But then land cover is the other one, is the next one. And so land cover is, as I mentioned before, it's how is the land being used? NASA has satellites going around the Earth, and they're looking to see how the land is being used. Now we can calibrate, once again, those satellites and help them map out how land is being used. Is it a meadow? Is it urban where people are living? Is it a big park? And so it actually figures out the code for it. And it has things where it walks you through it, like trains you. This is like a training thing to train you how to do it. And then it has you do it. And the last one is, of course, as I said, my favorite is the tree one. And the tree one, you can make new observations on it, and it will walk you through with that tree. It'll have you it'll have you put your information in, how tall you are. And so it wants to know how tall you are because it wants to know where the little camera is. And so here, I'll do it with my other phone. It'll let you know where the camera is, because you always keep the camera at your eye. It'll have you take a picture of the base of the tree, so we'll still keep it at my eye. And then I'll have you take a picture of the top of the tree. But notice I keep my camera right at my eye level. What I've seen some people do by accident, the base of the tree, they'll hold the phone down here. Oh, the height of the tree, they move their phone way up here. They're moving their phone. Well, if we talk about the geometry of what it's doing, it's making a triangle, a right triangle. And so we need that central point. What's the edge of a triangle called, Sarah?
Yeah, the edge of a triangle?
Yeah.
The base of the triangle?
No, the corners. What were the corners called?
Oh, the corners of the vertices?
Yeah, the vertices. Oh, she's a math teacher, used to be. I always ask weird questions, just like her students did. But yeah, keep that vertices where it is. And so that's why at the base of the triangle, the bottom part of the triangle, right, where that right triangle is, we keep that right there in one spot. So when you go to do the tree height, and it's really cool. Imagine doing a tree in your front yard, doing the height of it, and then next year come back and do the height of that tree again and see how much your tree is growing. And so you could do that with all the trees. You could do that in the park. Again, I'm bringing in my daughter because I know the kid. She used this app to do tree heights of our local park. And then she went on and did a carbon footprint calculator to see how much carbon our local park was storing.
Wow, that's really cool.
Yeah, there's so many neat things you can do with this.
And so the kids at home can do any of this, right?
Yes.
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 And again, remember, if you do sign up for this, please consider joining our virtual school with a capital I, capital N, lowercase science, because then the measurements that you take for any of these will be logged with our Purdue virtual school, and we'll be able to see all the great measurements that you're contributing.
Which is really cool.
And what another really neat thing is when you go onto the Globe website online, not only will the pictures and measurements that you put, you'll be able to see pictures and measurements all over the world. Which brings us to when you do the pictures. All right, it'll have you take pictures of the clouds, right? And it also has pictures take up and down. No people in the pictures. I know that's no fun, but no, we can't have pictures of people pictures in there. And if you do, it'll get kicked out. It won't be used. And so don't submit pictures of people, please, because it won't be used. And so I've got away with like a foot here or there when I was doing the ground, but that's about it. I've always been careful not to get people in it anyway. I know I've had some groups where, they like, here, I'll be in it. And that picture you'll never see. It's gone.
Yeah.
And that's just to keep everybody safe.
Yeah.
Mm-hmm.
So you were saying that you need either cell connection or Wi-Fi to be able to actually upload observations. But is it true that you can take observations and then when you get back to internet, you can upload those? So does it save it within the app and then?
Yes.
Okay.
Yes, it does. Yep. And that's a great point. We've actually used iPads that only connect with Wi-Fi, and we've taken many, many observations, and it stores all of them right in the app. And then as soon as we're back with Wi-Fi and we connect it, it just uploads everything right there. So yes, that's exactly true.
Yeah. Great.
So I have a question about clouds.
Oh, okay. Go back to clouds.
Back to cloud.
How are there more or less clouds on different days?
That's a great question. And that a little bit of that has to do with temperature, and also it's also affected by the pressure of the atmosphere. And so you'll hear different times if you've listened to weather reports, like we have a high pressure front coming through or a low pressure front coming through. And so the pressure has to do with the amount of water that the atmosphere can support. And so if we have a lot of pressure, it can hold a lot more water in that without having it condensate out of the atmosphere. And so on high pressure days, you're going to see much clearer skies. When our pressure drops, when it's a lower pressure, our atmosphere can't support as many water droplets for that. And so those water droplets come out of the water vapor phase, condensate on those cloud nuclei, and then that's creating a lot more clouds.
So all of those variables she talked about are included. So it's to say from day to day or just minute to minute why the clouds change. The amount of clouds is so many different things, what we call the variables, like Sarah was talking about. Maybe the temperature is getting a little warmer. Maybe we have a front coming through, and that front is a difference in the air pressure itself. And I expect tonight we'll have a front coming through because it's supposed to be cooler, or it's supposed to be warmer the rest of the week, but it's supposed to get a lot more rain. And so I expect it to be a little lower pressure, and that can't hold that water vapor. So the water vapor has to condensate out. Remember, the clouds are made from those little water droplets. And so once they get too big, they'll fall out.
Can you do globe observations all year round, or is it just a summertime thing?
We want globe observations as often and as many times as you can take them. So yes, multiple times a day, as many times throughout the year as you can. They appreciate every measurement that you can submit.
They even have competitions. They have competitions. When they're doing a big research campaign, a couple of years ago, they were doing a cloud campaign. And they really wanted everyone to do clouds. You could submit up to 10 times a day. And then they would list on the NASA website the people who had the most cloud observations.
Oh, it's super cool. So how long has Globe been around? Globe Observer been around?
Well, it's really exciting. This year on Earth Day marked the 25th anniversary of the United States participation in the GLOBE program. And I believe that the GLOBE program was even in existence before that.
We're getting lots of questions about mosquitoes and trees.
Yes.
So it was the 25th anniversary of the actual GLOBE program itself. It started here in
of the GLOBE program. Okay. Yeah.
All right, so what, I hate mosquitoes. What's your question about mosquitoes? Why
do they bite?
Blood.
What was that?
Why are they attracted to blood, or why do they want to bite us?
Sarah?
Well, mosquitoes feed on the blood. So they're attracted to, I believe, I think it's body temperature. They can kind of sense that, and then that draws them to you. And they're a little bit of what causes the itch when they're drawing the blood, when they make that bite, a little bit of the saliva then leaves them and gets into you, and then that's your body's response then is to start itching because it has a little bit of that mosquito saliva in.
Nice.
And then I forget the other questions.
Yeah, one more about mosquitoes, and then we're done with mosquitoes. Are mosquitoes everywhere in the world, excluding Antarctica?
That's a great question too.
Probably.
I'm thinking probably, yeah.
Probably.
Probably, yeah. We don't know. We don't research mosquitoes.
That's a heck of an answer.
How much water can a tree drink?
Ooh.
Boy, that's the start of a note. How much water can a tree drink?
Yes.
Yes. A lot. It holds a lot of water. I don't know how much myself. I know it's a lot of water they hold.
Yeah. I have a couple of questions for both of you, Stephen and Sarah. And we'll start with Sarah. How long have you been doing this, either the observations or K through 12 learning, and what made you want to get started with this?
Well, I started my career as a math and chemistry middle and high school teacher, and so I started that a long time ago. I taught for about 14 years, and then 3 years ago, I came to Purdue as a K-12 outreach coordinator, where I get to help other teachers find resources to teach science, and I get to work with K-12 students. So I get to do great programs like the GLOBE program and different activities with students, and I also get to work with research scientists at Purdue. And I just wanted to get involved because I love helping students. I love science, and I like doing science myself and learning new things myself. I love learning new things from students and from other teachers. And so this is just kind of the perfect job to get to experience all of that.
Awesome. And how about you, Stephen?
Mine, I really didn't know what I wanted to do in school. I didn't want to go to college. I wanted to get something done. And yeah, then I've been in college most of my life since then. But it's so I did other jobs. You know, I had some factory jobs, construction jobs, and when I had off days, my wife was a teacher. I would either volunteer in her classroom or other classrooms at school. And I just really liked helping people learn. And even in the jobs that I was in, I always ended up in a trainee as a trainer. So I was always training the new people. I just liked helping people learn. And so my wife talked me into going back to school and going ahead and getting a teaching license. So I picked up my teaching license, but then there was opportunities at Purdue to do outreach. And so I'm like, well, that sounds really cool. I can help a lot of people. And so I ended up for 20 years now, I've been doing outreach for Purdue. But it was kind of one of those things. I'm having fun, so I'm going to keep doing it.
Awesome. Awesome. I have one last question for each of you. And this is something that we've been asking all of our guest experts. And that is, what is one thing that you wish the entire world knew about? Because you guys do K through 12 outreach, I'll let you pick the topic. But what is one thing that you wish everyone in the world knew about something?
Well, I wish that everybody in the world knew that they have the power to be a contributor to the scientific community. Everybody, even kindergarten students, can contribute to science. And one great way that everybody can help contribute is through the GLOBE program, which is why we chose this today to present. Your measurements matter. Real NASA scientists, not just NASA scientists, real scientists everywhere can use the data that you help collect and share that with everyone and learn and continue doing science. It's all one great big process. So I just think that everybody, every one of us has the power to help the scientific community.
I would really echo that. I tell you what, early in school, I wasn't the best student in the world. And so I thought, you know, a scientist, I would never be able to be a scientist. But I really had a passion. I enjoyed it. And other people told me I couldn't be. And so I think my one thing is that everyone needs to know that you can really do anything in the world that you put your mind to. I mean, I've been on several continents doing science research now with Purdue. And as Sarah said, we picked the Globe Observer so that everyone can realize that everyone can do science. Anything you're passionate about, if it's clouds, if it's trees, if it's those dirty mosquitoes, anything you're passionate about, you can research, you can study. And even I say those dirty mosquitoes, maybe you're tired of getting bit by mosquitoes. And so you want to research down to figure out how to stop that. And so do that, please. Somebody, please figure out how they stop biting me. But that's the big thing is you can do anything you want. You can be anything you want.
Awesome. Well, great answers.
Thank you.
We really appreciate you guys joining us today. Everyone at home in your living rooms, give Stephen and Sarah a quiet round of applause. They won't be able to hear you, but they'll pretend like they can hear you. Do not forget, tomorrow is the last day of Virtual Conservation Live, so please join us again at 11 a.m. Let me see if I can pull up the flyer for the 11 o'clock real quick. We'll be learning about drinking water, aquifers, pollution, things like that, and where we get our drinking water here in the greater Lafayette area. So tune in 11 o'clock. If you don't already have the Zoom link, it's there on the screen. Please write it down. Otherwise, feel free to join us on Facebook Live again. We'll try to get to all of the questions that we have, but that is all the time we have today. Thank you again, Stephen and Sarah. We will see you guys again soon. Thank you, everyone, for joining us. Have a good afternoon.
Bye-bye.
Thank you. Bye.